We are just solving today. Title of our lesson is Solution of Equations, Lesson 25. And we're applying those inverse operations and those rules that we just learned in our last two lessons. We kind of have our jingle that goes along here, kind of like our Shirley English jingle. 4x plus 5 equals 17 is our equation we're solving. What's our goal? Our goal is let's get x by itself on one side of the equation. Do we have x by itself on one side of the equation? No. What are we doing to poor little x? We're both adding 5 and multiplying by 4. So I could almost write that over here. We're adding 5 and we are multiplying it by 4. So we're going to have to undo these two things. So we use inverse operations to isolate the variable, get x by itself. In other words, we're going to have to subtract 5 because that's the inverse operation of addition, subtraction is. And we're going to have to divide by 4 or multiply it by its reciprocal. One of these is going to make our life easier. Both would work. We could start with either one of these steps, but it's going to be easier if we subtract the 5 first. And what we do to one side, we do to the other. Negative 5 and positive 5 cancel out. We've got 4x equals 17 minus 5 is 12. Do we have x by itself? Nope. We are still multiplying x by 4. It's not by itself. We knew that we were going to have to divide by 4, which is the same as multiplying by 1/4. Four over 4 is the same as 1. 1 times x is x. X equals 12/4. And 12/4 simplifies to 3. Let's do another example. Negative 7k minus 4 equals negative 21. Our goal is to get k by itself on one side of the equation. Isolate the variable. It is not by itself. We are multiplying it by negative 7. And we are also subtracting 4 from k. So we are going to have to divide by negative 7. And we're going to have to add 4 because those are the inverse operations. Again, we could start by dividing both sides by negative 7 and we would eventually get the right answer, but it's going to make things a little bit more complicated because we have to divide the whole side here by negative 7, so we'd have to split those terms, and we could do it, but it's going to be a little bit easier if we start with adding 4 to both sides. What we do to one side, we do to the other. Equals negative 17. Don't have k by itself, still multiplying it by negative 7. How do we undo that? Divide by negative 7. What we do to one side, we do to the other. These reduce to 1. K equals negative 17 over 7. The two negatives cancel out because a fraction is a division problem. When we divide a negative by a negative, we get a positive number. So our answer is 17/7. Two more. Next one deals with fractions. It's really set up the same way. Our goal is still to get m by itself on one side of the equation. We do not have m by itself. We are both multiplying it times 1/5 and subtracting 1/2. So the two things we're going to have to do, since we're multiplying by 1/5 and subtracting 1/2, we are going to have to divide by 1/5 and add 1/2. We'll start by adding 1/2. It's going to make life easier. What we do to one side, we do to the other. These two cancel out. 1/2 is the same as 2/4. We need a common denominator. So 1/5 m equals 5/4. We still do not have m by itself. We are multiplying it by 1/5. So we're going to have to divide by 1/5, which is the same thing as multiplying by the reciprocal, or 5 over 1. Do the same thing to both sides. Sorry about my pen there. So m equals Try to clean this up a little bit here. 25 over 4. And if we want, we can leave it as 25 fourths or write it as 6 1/4. Either is fine. Last one. Here we've got a decimal. I don't have much room on my board here. Here we've got a decimal. 0.4x minus 0.2 equals negative 0.16. Doesn't matter that it's a decimal. We still follow the same process. So what are we doing to, or trying to get x by itself? We don't have it. We are multiplying x by 0.4 and subtracting 0.2. So we'll start by adding 0.2. What we do to one side, we do to the other. These cancel out. 0.4x equals, here, this is a little bit trickier, but really what we have is 0.04, and it's positive. And we've got to divide by 0.4 and divide by 0.4. At this point, I'm starting to think to myself, man, these decimals are kind of a pain. Now when I look at this, I say, what is that? I know that a fraction is a division problem. I think I'm better off just writing this out. And so I move the decimal over here. I move the decimal over here. My new problem is 4 into 0.4. And I see that my answer is 0.1. And I did get there. The answer is 0.1. But I didn't really like working with those decimals a whole lot. So there's an easier way to do this problem. Well, it's, I guess, a personal preference or an opinion whether or not you think it's easier, because it is going to mean more work. But to start off with here with this problem, if we just kind of go off to the side here and look at this property, if we have 2 plus 4 equals 6. If we multiplied every term times 10, times 10, times 10, times 10, we'd have 20 plus 40 equals 60. It is still an equation. It's still true. If we were to multiply them all by 100, we would have 200 plus 400 equals 600. And we can keep going, and we're going to find out that if we multiply every term in the algebraic equation here by the same number, it's still going to be equal. And so we apply that here to this problem, because if I multiply all these terms by 10, actually let's make it 100, because this has 2 decimal places, every term by 100, I'm going to get rid of the decimals and then I don't have to deal with them at all. So this becomes 40x minus 20 equals negative 16. I like this a little bit better. We're going to get the same answer, you'll see. So now we've got 40x equals positive 4, divide by 40, divide by 40. And so again, you could just reduce this here. 1/10. We know that 1/10 is 0.1. Sometimes people like to multiply to get rid of the decimals, but you do not have to do that. So we are solving today. Nothing new. We've been doing this for a while, using our inverse operations to solve equations, isolate the variables.